Welcome to Ask and Learn.
We're given a deterministic finite state automaton, and we are asked to find the language recognized by this automaton. The automaton is found in problem 21 of this section. We see on the automaton that there are 5 states, six states, S0, S1, S2, S3, S4, and S5. So I'll draw a quick table here, and on the left-hand side, I'll write the different states. And on the right side, I'll write the inputs, which can only be 0 or 1. And now, if there's an arrow from state Si to state Sj, which has a label of x, then I'm going to write Sj in the row Si and under the column x in this table. So for example, we see that there is an arrow from S0 to S1 labeled 0. And so I'll write S1 next to S0 and under 0. And likewise, I can complete the rest of the table. And we see from the graph that states S0, S3, and S4 are all circled twice, which means that these states are final states. So we have that a string is recognized by the automaton if it ends at one of these 3 states. And we also see that S0 is marked as a start state. Okay, so let's consider different cases here. So first, suppose that the string is empty. So the string is the empty string lambda. Then we see that since we are starting at S0, we're of course remaining at S0, which is a final state. And so it follows that lambda is a subset of the recognized language. Now, let's suppose that the string starts with a 0. Then according to our table, we're going to move from S0 to S1. And we see that if we suppose that the remaining string is only 1s, then it follows that we're going to be stuck at S1, which is not a final state. So instead, let's suppose that the remaining string contains A0. Then we're going to move from S1 to S3. And we see that once we're at S3, if we don't have any more bits, then this string is going to end on a final state. So it follows that all strings of the form 0, 1 star, and then 0, these are in the recognized language. Now, let's suppose that instead of starting with a 0, we start with a 1. Then, according to the graph, we're going to move from S0 to S2. And we see that at S2, no matter what we input, as long as we suppose there is another bit, we'll move to S4. So we'll move from S2 to S4. We see that S4 is an end state, and we see that no matter what we choose at S4, including the empty string as an input, we're always going to end up right back at S4. And so it follows that we're going to remain at S4. And therefore, we have that set 1, 0, 1, and then 0, 1 star, which is the same as 1, 0, 1, 1, 0, 1 star, is a subset of the recognized language. Now for the next part, going back some, suppose that we're at state 1 and okay. So let's suppose that we are at state S3, which we know we can only get to through 0, 1 star, 0 coming first. And now, suppose that the remaining string has a 0. And in fact, not just the remaining string has a 0, but suppose that the next bit is a 0. Then according to the graph, we're going to move from state S3 to state S5. And then once we're at state S5, we see that we're only going to move to S4 if the string contains another 1. So suppose string contains, or the remaining string has a 1, then we're going to move from S5 to S4. And we see that regardless of the input, we're going to remain at S4. So this is really, strings like this belong to the set 0, 1 star. Zero, and then the next input is another 0. So that's the one that takes us to S5. And we see at S5 we can have any number of zeros, so a 0 star. But then we have to also have at least one 1, so we'll add a 1. And that takes us to S4, and we see that at S4 we can have any string remaining, so 0, 1 star. All right, and that can actually be abbreviated as 0, 1 star, 0, 0, 0 star, 1, 0, 1 star. This is a subset of the recognized language. Now, we're still at S3, but suppose that the next input, instead of being a 0, is a 1. Then we're going to move from S3 to S4. And of course, we see that we'll remain at S4 regardless of the input. And so strings belong to this set 0, 1 star, 0, and then the next input is a 1, so we have a 1. And then after that, we can have any input, so 0, 1 star. And this can be rewritten as 0, 1 star, 0, 1, 0, 1 star. And this is a subset of the recognized language. My mistake. Yeah, okay. And so these are all the different cases. And so it follows that the language generated by this automaton is the union of all these different sets. So we have first lambda, and then we also have union with 0, 1 star 0. Union with 1, 0, 1, 1, 0, 1 star. Union with 0, 1 star, 0, 0. Zero star, 1. 0, 1 star. Union with 0, 1 star, 0, 1, 0, 1 star. And at this point, it doesn't seem like this is really something that can be simplified, so this is our answer.